Students, in the previous videos, we've seen the various graphs of the distance, displacement, velocity and acceleration time graphs. Now we are going to see this another graph. This is a variable graphs. So velocity and acceleration taken in a y-axis, as usual the time in the x-axis. So this is a variable velocity. The velocity is not a constant. Here the acceleration is not constant. So the both the graphs represents a variable acceleration of an object. So for calculating a displacement in velocity time graph, very simply you have to calculate the area under this curve. So the area 1, area 2 and area 3. In order to calculate the displacement in this velocity time graph, you have to add the 1 and 3 and subtract area 2. So what is this area 2? It is a negative velocity. The displacement is negative. That means the body is moving from one point to another point. In this graph what will happen? It will return back to this origin. After that what will happen? Again it will move forward. So that only it will represent here. So we can calculate only the shortest distance between the initial and final point is displacement. So we have to subtract area 2 from area 1 and 3 in order to calculate the displacement covered by an object in this curve. So this curve is a variable acceleration curve. For calculating the displacement, add the 1 and 3 and subtract the area A2. If you want to calculate the distance from this curve, you have to add all the three areas very simply, because it is an actual path traveled by the body. So I will say that here it is an origin. Okay, the body is moving. So when it is this curve, this is the distance covered in this area under the curve. So after that what will happen? The velocity is decreases. That means the displacement is decreases. Again the body is return back to certain distance. So this is a point A. Then it comes to the point B. After that what will happen? Again the velocity increases. So the displacement is positive. It reaches the point C. So what we have to do that? We have to subtract this one. So this one we no need. So the shortest distance between the initial and final point is displacement. So only we are subtract the area 2 in displacement calculation. For distance calculation, the actual path traveled by the body is called as a distance. So we have to include the area in this calculation. I think the students are very clear for the displacement calculation and distance calculation. Similarly for acceleration time graph, this velocity has to be added in 1 and 3 and we have to subtract the velocity in order to calculate the change in velocity. So area 1 minus area 2 plus area 3. Then we are going to see that a speed time graph. So these two graphs easily represent. This first graph represents when a body is thrown in the upward direction, what will happen? The ball is moving in increasing velocity or increasing speed. Sorry, the body is moving in decreasing speed. When the ball is moving upward, the speed decreases at the maximum height, the speed becomes 0. After it coming down, after the maximum height, what will happen? The ball come with the increasing speed. So only the graph shows here. Here in this case, the ball is dropped. This is a starting point. The ball is dropped from here. So what will happen? The speed increases. The speed increases, it increases. After it reaches the ground at the time t, what will happen? It bounces back. So when it is bouncing back, the speed decreases. At a maximum height it attains, what will happen? Again speed increases. We have to draw the graph like this. Again like this one. So what will happen? The graph goes on decreasing, because as the ball drops from the height, from the certain height to the ground, it will bounce back and comes to the rest. So this is a speed time graph for the ball dropped from the height. This is the speed time graph for the ball thrown upward direction. Dear students, I will show this page very slowly for copying this. The first graph represents the variable acceleration with velocity time graph. Second graph is also represents the variable acceleration with acceleration time graph. So in this graph we are calculated the displacement and the distance. Here we are calculated the change in velocity. And finally we seen that speed time graph for two cases, when the ball is thrown upward and when the ball is dropped from the certain height. Yes, students. So far we are seeing that different graphs. Now we are going to see one of the example, one by one problems. However, if you are seeing the different graphs, it may be confusing you. So only we are going to move to the problems. If you solve the problem, it is easy for you to understand the graphs very clearly. So the problem 1. The distance time graph of the two trains which starts moving simultaneously in the same direction. So there is a two trains A and B. So the train A starts moving from the origin, but at the same time the train B is ahead of 100 kilometers. So this is the distance. So the 100 kilometers ahead it will be there. So it starts moving. This is the graph given in the question itself. So now we are going to answer the one by one question. How much ahead of the how much distance ahead the A is B? That means A is from the A, B is how much distance it is ahead. Very clearly from the graph we are able to see that the distance at the time t is equal to 0 for the A train is 0. For the B train is at time t is equal to 0. This is the time at the time t is equal to 0. The distance covered by the train B is 100 kilometer. So that means it is at rest. It is in motion at the distance of 100 kilometer. The second question. What is the speed of the B? So how to calculate the speed of the B? Very simple. It is a distance time graph. In order to calculate the speed, just you to take the slope of the curve. So what is the speed of the B? So you have to take the slope of the B curve. So this is the curve B. You have to take the slope. QR and PS. Slope means y divided by x. Y-axis divided by x-axis. Here the y-axis is QR and x-axis is RP or PR. Slope which is equal to QR by PR. So what is the Q? Q is the 150 and R is the 100. Q is the 150 kilometer and R is the 100 kilometer. For this one, here the R is the 2 seconds and here the initial is 0 seconds. So 0 seconds to 2 seconds. So 2 minus 0. 150 minus 50, 100 and 2 minus 0. You can ask that. Why is it 0 minus 2? So we have to take the slope. So that is a 2 minus 0. Time never be a negative. Time is always positive. So you have to subtract with bigger value minus smaller value. So 150 minus 100 is a 50 and 2 is a 2. So we get an answer 25 km per hour is the speed of the train B. So the next question. When and where will the A catch B? So when and where the train A catches B means by seeing the graph itself it is easily understand. At the point Q both the trains will meet. So at the distance of 2 hours, at the time of 2 hours at the distance of 150 kilometer. So the A train catches B. So the A train catches the B at the distance 158 kilometer at the time 2 hours. So two graphs intersect at Q, hence A catch B after 2 hours and at a distance of 150 km from origin. The next question, what is the difference between speed of A and B? What is the difference between the speed of A and B? Already we have calculated the speed of B. So now we are going to calculate the speed of A. So how you can calculate the speed of any slope in any graph? In the distance time graph means what is that? If it is a distance time graph, the slope represents the speed. So train A slope is QS and QS and here it is 50. So 150 this one. This is a y-axis. So QS and OS. Y-axis is a QS and x-axis is OS. So we can write that speed is a QS by OS. QS is 150 minus 0 and the time is 2 minus 0. Again don't say that it's our initial position 0 and final position 2. So time never be a negative. So bigger value minus smaller value. So 150 by 2 it is a 75 kilometers. So the difference in speed is 75 for A and B is 25. Just to subtract these two things we get an answer 50 kilometers. So very simple students. So this curve represents the motion of the two trains. The one train is moving forward ahead with the 100 kilometer. After that sometime what will happen? Train A catches B. So that is a question asked in this problem. Thank you students.